Hello friends, in today's video lectures we will see another very important concept which is of unit number second, chapter number second, superconductivity. So this topic is a completely new topic in today, and it having vast demand in every kind of field where we use superconductors. You know semiconductors, you know conductors. Now the new term that you have to understand, that is superconductor. Okay, the superconductor is the phenomena superconductivity is we want to discuss. How it is discovered, let me see here. Discovery of superconductor. On the basis of thermodynamic aspects, Lord Kelvin in 1848 suggested that lowest limit of temperature is absolute zero. You know absolute zero temperature? The temperature at 0 Kelvin is called as absolute zero temperature, or a temperature of minus 273 degrees Celsius, that is also called as a absolute temperature, or it is also called as a absolute zero temperature. What is that actually? The absolute zero temperature is the temperature where liquefaction of gases takes place, right, at very low temperature and very high pressure. What is liquefaction? That is conversion of gaseous substance into liquid substance. So that can be done at very low temperature and high pressure. That is called as a liquefaction of gases, and that liquefaction of gases mostly take place at absolute zero temperature or very near to absolute zero temperature. Okay, everybody understood? For example, a gas which is present in a LPG cylinder, that is a you know the meaning of LPG. LPG means liquefied petroleum gas. So here liquefied petroleum gas, that means a gas which is present in a liquid state under very high pressure in that cylinder. Okay, so that is called as a liquefaction, and mostly liquefaction of gases takes place, as I said earlier, in a absolute zero temperature. That concept was introduced by Lord Kelvin. Once we do a liquefaction of gases, then their properties, changing the properties of substance at lower temperature, and that is the very interesting thing that is found in a scientist called as Dutch scientist Kamerlingh Owens. That means if you change the original condition or original state of that particular substance, that means convert gaseous substance into liquid substances or liquid form, so at that time some properties of that substance will get changed, and that properties are very interesting. So first time Dutch scientist Kamerlingh Owens pursued throughout his life the research for obtaining a very low temperature and succeeded in a liquefaction of gases. So first time liquefaction of helium is attained at very low temperature, and the temperature is only 2 Kelvin temperature at atmospheric pressure. This is the discovery done by Owen, where helium gas is converted into liquid helium at temperature 2 Kelvin only at atmospheric pressure. And for this discovery, that particular person, that is Kamerlingh Owens, got a Nobel Prize in 1930. So that is the one of the prestigious award given in the field of chemistry, right? It's just yesterday two lady persons also got a Nobel Prize for the discovery of DNA, gene coding. So for his investigation of the properties of matter at low temperature, which leads to the production of liquid helium. Okay. So K1 devoted his research for the studies of various properties of matter at very low temperature, one of which was the variation of electrical resistance. He closed mercury matter for his studies since it can be purified by distillation. Right. So the phenomena of superconductivity is very important today, because in so many electronic devices we are using superconductors. Even in a computer also we are using a superconductors. So we will see two important terms. One is called as superconductor, second one is called as a critical temperature. So that terms are very important for examination point of view, and also for understanding the concepts of superconductivity. In 1911, K. Owens discovered a phenomena, and he found that low temperature research has led to the discovery of amazing phenomena of superconductivity. So K. Owens is also called as a low temperature research scientist. For a long time, it had been known from the conductivity experiment that electrical resistance of metal decreases with decreasing temperature. You know what is the resistance? Reciprocal of conductance is called as a resistance according to Ohm's law. So the conductivity experiment stated that the electrical resistance of metal decreases with decreasing temperature. As temperature decreases, electrical resistance also goes on decreasing. You know what is resistance? Resistance means it is exactly opposite to conductance, or resistance is defined as a thing which resists to flow the current. That means which is not able to carry the current. So that is called as a resistance. He found that the resistance of mercury decreases with decreasing temperature, and it falls to an extremely low value, which is almost zero resistivity at 4.15 Kelvin. That means when helium is liquefied at 4.15 Kelvin temperature, the resistivity of that helium is completely zero, absolute zero, right, which impart very high electrical conductance. As I said, if the resistance becomes zero, then conductance will become high, because as I said, according to Ohm's law, resistance is reciprocal of conductance. So electrical conductance increases with decreasing electrical resistance. That phenomena you have to remember. It has been found that number of metals and alloys, the electrical resistance disappear abruptly. Means what? Sometimes what happens? Electrical resistance goes on decreasing slowly with increasing temperature. But here, decreasing temperature. But here you can see that for metal and some alloy, that electrical resistance decreases abruptly or suddenly and reaches to minimum, and a very few above absolute zero. That is very low temperature. Pure mercury almost shows zero resistivity at absolute 4.15 Kelvin or below 4.15 Kelvin temperature with very high electrical conductance. And through this experiment, who got the Nobel Prize to that particular scientist, K. Owen, he made a definition that the phenomena of abrupt disappearance of electrical resistance at very low temperature, which impart very high electrical conductivity to the conductor and making it superconductor. That is called as a superconductivity. That word that is called as Superman. What is the basic difference between man and Superman? Man is an ordinary person, but Superman is such a person which having some extra ability or extra caliber to do something, to do something better than the common man. That is called as a Superman. Okay, so in one of the serial, that is Shaktiman, we saw that Superman who can also climbing on the wall, so that normal people or normal person cannot climb or cannot walk on the wall, but Superman can walk on the wall. So same thing is here. Abrupt disappearance of electrical resistance. Abrupt disappearance of electrical resistance at very low temperature, which impart high electrical conductivity to the conductor and making it superconductor is called as superconductivity. Everybody understood that phenomena? Very important for examination point of view. Now next important term that we want to define, that is a transition temperature or a critical temperature. Okay, so what is transition temperature or critical temperature? Let me see. Materials are said to be superconducting when they offer no resistance or zero resistance. What is called as a conducting material? Which allow to carry a current. Those material which will not allow to carry a current, that is generally a resistance, they having very high resistance to carry the current, so it offer a no resistance. But a material which are said to be superconductor, that means they differ, they offer no resistance or they offer zero resistance to the passage of electricity. For example, copper wire. So in copper wire, electricity is easily passes. So copper wire is a good conductor, but rubber, if you take, it is a bad conductor. Why it is called as a bad conductor? Because rubber electricity is not transferred through that rubber. So rubber is the good example who shows the high resistance power to passage the electricity. The temperature at which superconductivity occurs is called as a superconducting transition temperature or critical temperature. Temperature, what is critical temperature? Or temperature where superconductivity occurs, the temperature at which superconductivity takes place is called as a critical temperature, which is denoted as Tc. Materials are said to be superconducting when they offer no resistance or zero resistance to the passage of electricity. At ordinary temperature, a metal has a measurable resistivity. Normally at room temperature or ordinary temperature, where we some portion of electricity can be passed through that material, so there is a absolutely no zero resistivity, but resistivity decreases and conductivity increases at a certain temperature. The temperature is called as critical temperature. The temperature at which material undergo electrical conductivity is called as a electrical conductivity transition or a superconducting transition temperature or critical temperature. There are these three different meanings: superconductor, critical transition temperature, or we can say electrical conductive transition temperature. The temperature below which material shows zero resistance, it is denoted to by Tc, or the temperature with maximum or the maximum temperature at which superconductor exhibits superconductivity is called as critical temperature. That means there are two ways we can define the critical temperature: one above, other below. Again we will see here the temperature below which material shows zero resistance, that is called as a critical temperature, or the temperature above which material shows superconductivity behavior is called as a critical temperature. So everybody understood that? You have to remember two important phenomena here. One is called as superconductivity and other is a critical temperature. So other things we will discuss in a next video lectures. Okay, bye.